So 1110 goes over using special factors to factor completely. If we look at the first examples, for example A, we have x squared plus 6x plus 9. You can use a special factor in order to completely factor this because it is a perfect square trinomial. However, if you did not know that, you can just see that you have that 9 that is your C term. You can find the factors that add up to be your B term, which are 3 and 3. And you can simplify this or factor it by doing x plus 3 times x plus 3. Because you have the same binomial more than once, you can take that binomial and raise it to the power of the amount of times that you have it. So that would just be x plus 3 raised to the second power. For example B, you have x squared minus 8x plus 16. So again, with this one, if you didn't realize that this was a perfect square trinomial, you can take the factors of 16 that add up to be negative 8, which are negative 4 and negative 4, and factor it as x minus 4 times x minus 4. You have two of the same binomials, so it's just x minus 4 to the second power. So with these, like we just mentioned, they are perfect square trinomials. If you were to factor a perfect square trinomial, you could take first out, like if we look at example 2a, you could take out your greatest common factor. From there, you can take the square root of the first term, take the square root of the last term, take the sign of your middle term, multiply the sign of the middle term times 2 times the square root of the first term times the square root of the last term. If that gives you that middle term, then it's a perfect square trinomial, and it just factors out to be a minus b squared, or a plus b squared. If we look at example A, I'm going to start this one by factoring out an x and only an x from each of these. The reason, no, I can factor out a 4 also because it is going to give me a perfect square trinomial still. So we're going to factor out the 4x. This gives us 4x times x squared minus 6x plus 9. You can take the square root of the first term. You can take the square root of the last term. It gives you x and 3. That middle term has a negative. So if we do negative 2 times x times 3, it gives us the negative 6x, which is that middle term. So we just factor it as 4x times x minus 3 squared. For example B, we have x squared plus 16x plus 64. Again, we can take the square root of the first term, we can take the square root of the last term, we get x and 8. The sign on the middle term is positive, so if we do positive 2 times x times 8, it gives us 16x, which is that middle term. So this just factors out to be x plus 8 squared. So you see here, once I took the square root of that x squared, I have x. Once I took the square root of that 64, I have 8. Those are the two terms that are being put in the binomial with the same sign as the middle term in your trinomial. And then we're just squaring that binomial. For our next example, we have 2y cubed plus 12y squared plus 18y. We're going to start this one by factoring out our greatest common factor, which is 2y. So this gives us 2y times y squared plus 6y plus 9. Again, take the square root of the first, take the square root of the last, keep the sign of the middle. We have y and 3 with a positive 2. It gives us that 6y, which is that middle term. So we just have 2y times y plus 3 squared. For example D, we have 100z squared minus 20z plus 1. So again, we're going to take the square root of the first term, which is 10z, take the square root of the last term, which is 1. Our sign in the middle is negative, so if we do negative 2 times 10z times 1, it gives us negative 20z. That is your middle term. So we're just going to have 10z minus 1 squared. Next, we're going to be looking at the difference of squares. When you have difference of squares and you're factoring them, you're going to be able to take the square root of the first term in that binomial, take the square root of the last term in that binomial, and then the sign between them is negative. When you do this, you're going to get an A, you're going to get a B. Your A is just the square root of the first term, your B is the square root of the second term, and you're going to put this into sets of parentheses as A minus B times A plus B. For example A, under example 3, we have x squared minus 49. If we take the square root of the x squared, we get x. If we take the square root of the 49, we have 7. There is a negative that separates the two, so it's going to be x minus 7 times x plus 7. For example B, we have 49q squared minus 4p squared. So again, we're going to take the square root of the first term, that gives us 7q. Take the square root of the last term, that gives us 2p. We have a negative between the two, so this factors out to be 7q minus 2p times 7q plus 2p. For example C, we have 16x to the fourth power minus 1. So again, we're going to take the square root of the first term, take the square root of the last term. We get 4x squared and 1. So we're going to have 4x squared minus 1 times 4x squared plus 1. If you realize here, that first binomial that we have is a difference of squares still. So we're going to take the square root of the first term and the square root of the last term. They're separated by subtraction. We get a 2x and a 1. So this gives us 2x minus 1 times 2x plus 1 times 4x squared plus 1. That 4x squared plus 1 does not get factored because it cannot be factored. There's a positive between the 4x squared and the 1, which means we do not have a difference of squares, so you cannot factor it. For D, we have x squared minus 144. So again, take the square root of that x squared, we get x. Take the square root of that 144, we get 12. We have subtraction between the two. So this is x minus 12 times x plus 12. If we look at example E, we have 81y to the fourth power minus 9y squared. Again, we're going to take the square root of both of these terms. We get a 9y to the second power and a 3y. This is going to factor to be 9y squared minus 3y times 9y squared plus 3y. However, if we back this up a little bit, we realize that we do have a common factor between these two that we can factor out. It is a 9y squared, so we're going to factor that out first so that way we can completely factor this. This is going to give us 9y squared times 9y squared minus 1. Now that binomial is a difference of squares also, so we're going to take the square root of each of these terms. We get 3y and 1. So this is going to factor out to be 9y squared times 3y minus 1 times 3y plus 1. Now this is completely factored, so that is your answer. The last part of our lesson goes over factoring completely. So the first thing you want to do is to factor out the greatest common factor if you can. From there, look to see if you have a difference of squares or if it's a perfect square trinomial. If it's neither of those, find the factor, if it's neither of those and your A term is 1, find the factors of your C term that add up to be your B term, factor that way. If your A term is not 1, multiply your A and your C, find the factors that replace your B, factor by grouping. If you have more than 3 terms and you only have 4 terms, factor it by grouping if you can. If you want to check your answers, multiply everything out, and you should be getting the same exact thing that you started with. If we look at example 5, we're given negative 4n to the fourth power plus 40n cubed minus 100n squared. And we're factoring this completely. So the first thing we're going to do is factor out the greatest common factor, which is going to be a negative 4n squared. This is going to give us negative 4n squared times n squared minus 10n plus 25. From here, check to see if this is a perfect square trinomial. You can take the square root of that C term, and your A term is 1. So if we took the square root of that 25, it gives us 5. If we take the square root of that n squared, it gives us n. Our sign in the middle is negative, so if we do 2 times n times 5, it gives us that negative 10n, which is that middle term. So we can factor this as a perfect square trinomial, which means we're going to have a minus b raised to the second power. So this factors out completely to be negative 4n squared times n minus 5 raised to the second power. For our next example, we have 5a cubed b squared plus 3a to the fourth power b minus 2a squared b cubed. Our greatest common factor between all of these terms needs to be factored out first. All of them have an a squared, so we'll factor out an a squared. All of them have a b, so we'll factor out a b. This is going to give us a squared b times 5a b plus 3a squared minus 2b squared. For this trinomial that's left over, we can rewrite it as 3a squared plus 5ab minus 2b squared, so that way it's easier to work with and it looks a little bit better to us. From here, we have an a term that's not 1, and we do not have a perfect square trinomial because you cannot take the square root of 3a squared. You cannot take the square root of negative 2b squared. So we're going to multiply that first term and that last term. We have 3 times negative 2, which is negative 6. We want the factors of negative 6 that add up to be a positive 5. If we have a negative 1 and a positive 6, that gives us our positive 5. So we're going to rewrite this as a squared b times 3a squared minus ab plus 6ab minus 2b squared. Now that we have 4 terms, we are going to factor by grouping. So set parentheses around the first 2 terms, set parentheses around the last 2 terms. Factor out your greatest common factor from each set of parentheses. From the first, we factor out an a. From the second, we factor out a 2b. So this becomes a squared b times a times 3a minus b plus 2b times 3a minus b. Your 2 sets of parentheses are identical to one another, so we're going to just rewrite this one more time as a squared b times 3a minus b times a plus 2b. We check to see that everything is factored out completely in there, which it is, so we now have our final answer. For our last example, we have a squared bc minus 4bc plus a squared b minus 4b. And we're factoring this completely. We do have 4 terms here, so we're going to first try to group the first 2 terms, group the last 2 terms, and factor by grouping. From the first set of parentheses, we can factor out a bc. From the second set of parentheses, we can factor out a b. So this is going to give us bc times a squared minus 4 plus b times a squared minus 4. Your 2 sets of parentheses are the same, so we're going to have a squared minus 4 and bc plus b. Now with this, you can factor out from that second set of parentheses a b, so that way you have b times c plus 1. From there, we look at that a squared minus 4. We have a difference of squares here. Our a is a, our b is 2. So this is going to factor out to be b times c plus 1 times a minus 2 times a plus 2. We double check, make sure everything's completely factored, which in this case it is. So that is our answer.